This video is all about nomenclature, naming covalent compounds, acids, and hydrocarbons. So just a couple pictures here. Covalent compound, a little Bart-Simpson action, and then a hydrocarbon. We'll talk about what those are in just a moment. Alright, so first of all, when we're talking about covalent compounds, we're going to focus primarily on naming binary compounds. So that's going to be two different nonmetals coming together. Now the first atom listed is always going to be your central atom. And we're going to name it with the full element name. Now we are only going to use a numerical prefix if there are more than one. The numerical prefixes that we're going to be using are provided down here. 1 for mono, di for 2, tri for 3, so forth and so on. We will always name the second element with a numerical prefix, regardless of how many they are. And just like in ionic bonding, we're going to drop the end and replace it with IDE. So on the example above, number 1 here, we have carbon, and we only say carbon, we don't say monocarbon because there's only one of them. And because there are 4 hydrogens, we use the prefix tetra, and hydrogen becomes hydride. This is probably not the greatest example, however, because you're going to learn here in just a couple slides that CH4 is also a hydrocarbon and therefore has a special set of names. But if you were to use the covalent naming system, this would be how you would name it. Now on the second compound, N2O3, we do have 2 of the first element listed. So therefore we have to specify that we have 2 nitrogens. Dinitrogen. And then the second word, trioxide. These are 2 examples of how we name covalent compounds. Acids are very similar in their formation, but can also be formed ionically. But they have slightly different rules as to how we name them. What gives an acid away is the fact that we're always going to have a hydrogen at the beginning, or at least one of them. Now we are looking a little bit with charges here, so we do have to kind of keep in mind that it could be 1 hydrogen, could be 2 hydrogens, so forth and so on. Now, of the 2 types of acid that we're going to focus on, we have binary and we have ternary or oxy. This first one listed right here, HBr, has 2 capital letters, H and B. Therefore, it's a binary acid. All binary acids are going to follow the same format. Hydro, blank, ic acid. And the blank gets filled in as the other element that's present. So in this case here we have bromine, so it's hydrobromic acid. This is not to be confused with HBrO3. HBrO3 is not a binary acid. Therefore, HBrO3 would not contain the word hydro. An example that's similar to this is below with HNO3. When we're focusing on oxyacids, we are always looking for the polyatomic ion. The polyatomic ion is NO3. The name of NO3 is nitrate. The rule that we're going to be following is this. An 8 will become ic, and an ite will become us. So nitrate becomes nitric acid. HNO2, however, would be called nitrous acid. Finally, we'll talk about hydrocarbons. Hydrocarbons are any compounds with the elements hydrogen and carbon. There's lots of examples out there. All of these would be considered organic molecules. CH4, C2H4, C2H6, C8H20, H18, C7H12, plenty of others out there. There's a special way of naming these compounds. They are very similar in the way that they're named and follow very similar to covalent compound rules. The prefixes, however, are going to be slightly different. Here are the list of prefixes. Meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. It'd be a good idea to have these written down, but they're also available on your naming rule sheet. When we name these, they're going to follow one of 3 different formulas. Alkanes contain only single bonds. Alkenes have some double bonds, and alkynes have at least one triple bond. The formula is going to fit into those. C to the x, h to the 2x plus 2, c to the x, h to the 2x, or c to the x, h to the 2x minus 2. So the first thing we're going to do to name these compounds is look at the number of carbons. The first one we have is C2. Well, 2 carbons, the prefix is F. So the number of carbons will determine our prefix. Then we must use the 3 formulas over here to determine the ending, whether it be ANE, ENE, or YNE. All of the formulas feature taking the number of carbons and multiplying it by 2. In this case, 2 times 2 gives us 4, but the number of hydrogens we have is 6. To get from 4 to 6, we have to add 2. 2 times 2 plus 2. The end of this is ANE, because the formula that we used is the number of carbons times 2 plus 2. The example below has 4 carbons, so we're going to start out with the prefix BUT, but. Automatically, we're going to take the number of carbons, 4, and multiply it by 2. And we get 8, which is the number of hydrogens. So all we had to do was 2 times x. 2 times x is the formula for the alkenes. So the ending of this one is ENE. That's all we have on nomenclature. We're going to have some Excels to practice in class.